In this video, I'm going to discuss flow work and the energy of a flowing fluid. So at first, we'll try to understand what is actually the flow work. Okay, what is actually the flow work? So if you see, guys, here, this is the work or energy that we need to push the mass into the system or from the system. So into the control volume or from the control volume to the out of the system. So that means we have a domain here. Look, this is, let's say, piston cylinder device. We have this control volume, this red dotted line. You know the definition of the control volume. So this is the control volume, and we have a very small fluid domain here with the volume V. So if we want to push the this fluid into this control volume, so this is actually control volume, so this fluid element, it is out of the control volume. If we want to push or enter this control this fluid element into this control volume, then we need some work should done, because we have this length here, and the definition of the work, it is actually related with the displacement. We discussed the definition of the work in maybe week 2. So in this elementary fluid element, if we want to move this fluid domain or the mass into this control volume, then we need some work here. So the work what we need to push this mass or this fluid into this control volume is work. Here, when we have the two things will happen, so the mass is entering into this control volume, and also the mass is just exiting through this outlet. So that means the amount of mass is entering into this system, and equal amount of mass is going out through this outlet. So this is a steady state, and the definition of the steady state, it's not related with the time, and the mass inside the control volume, mass change inside the control volume, it will be constant. That means no change. So that. So if we want this process, if we want to continue this process, that means the mass will enter into this control volume and it will go out. This is a continuous flow process. If we want to this continuous flow process, then we need some work, and this work, it is called the flow work. So now for better understanding, if I can show you here this slide, you can see it was this small elementary fluid domain, and let's say we have a imaginary piston here. Okay, so this is part of the fluid domain. So it is before entering. So this is before entering situation, and this dotted line is the control volume. When it enters, the after entering, it will be like this. So it will be equal to this pressure and volume that we will discuss now. So here, look, we have this imaginary piston. So if we apply the force here, and so what will happen? An equal amount of the force will get from the control volume. So that means what I said, the amount of force applied by the piston on the fluid will be equal to the amount of the force which is applied from fluid to piston. So that means we are applying the force on the piston, an equal amount of force will be applied on this piston by the fluid. So here what will happen, that means we're talking about it should be uniform, it will not change, it will be steady state. So now if I say we are applying the force F, and this we are applying the force F on this area A, right? We are applying the force, and P is the pressure, A is the cross-sectional area. Okay, A is the cross-sectional area. So what will be the actually the force applied? So if we are getting the pressure on this piston is P and area is A, so what is the force here? We know pressure equal force by area. So we actually know pressure, it is equal force over area. We know this definition. So here pressure is P, force is F, area is A. So F it is equal PA. So this is, we know, actually the force, this is applied on the fluid element. The force applied on the fluid element. Okay. So now, if we want to push this piston, or if we want to push this fluid element, entire fluid element into this control volume, then we need to work through this length, distance L, right? Because initially the fluid element is here. So if we want to push all of this fluid element into this control volume, we need to push it until this. That means through this length L. And the work done by pushing this fluid element into this control volume, it is actually the flow work, because some work is happening here. And this work, we can say this is the flow work. It will be, the amount of force you are applying and the distance L. So L. So now we know F equal PA. So if we write it as PA and L, so what we did, guys, here we just substitute the value F equal PA here, and now we know this area and length, it is actually equal to the volume. So this is PV. This is actually the work, the flow work. And if we want to calculate the flow work, for unit mass, then we can divide this, the both left and right hand side, by using the mass. Then it was the total, the flow work. So then the right hand term, it will be the pressure and the specific volume. We know the formula. The specific volume is the the volume over the mass. You know this formula. So this is actually the relation, that how we will calculate the flow work. And previously when we did, that's the different formula, you already know, so I don't want to confuse you. So this is actually the definition of the flow work. So if I quickly review it, guys, you can see we just use the formula here to get the force. So we get force equal pressure into area, and if we want to move or enter, or this elementary or very small fluid element entirely into this control volume, then we need to go through, the force must act through this distance. So initially now it is here, so it must go, this fluid element must go there, so we need to travel this whole length L. So the work will be the force into the length L. So I think you understand this. So you will see in next video I will try to explain how what will be the energy of a flowing fluid. So that's also important. So I think that's it.